In Jan 2012, question number 1, this is a histogram sum. The histogram in figure 1 shows the time to the nearest minute that a random sample of 100 motorists were delayed by roadworks on a stretch of motorway. So we have a histogram here, and remember, in a histogram, this region, this rectangles, they're proportional to the area. So the area is proportional to, this area is proportional to the frequency. This is the height, not the frequency. This is called the frequency density, height of this rectangle, and this is the class width. Let's start with what they asked for. Okay, so we have the data here, and the data shows that everything that we have here, there is a gap from 6 to 7, from 8 to 9, from 9 to 9, 9 to 10. That means we have to do a continuity correction. In order to do the continuity correction, everything has to be 0.5, so 6 has to be 6.5, lower boundary has to be 3.5, 8 has to be 8.5, and 7 would be the same as the previous one, 6.5, this would be 8.5, this would be 9.5, this would be 12.5, this would be 15.5, and on and on. So the first thing is to fill in the blanks, the frequency. We know the rule that the frequency is proportional to the area, so we can directly do it. So here upper boundary is 8.5, lower boundary is 6.5. So the difference between them, we can just subtract this for the class width, or we can just subtract this and plus 1. 8 minus 7 is 1, plus 1 2. So 2 is the class width. So 2 is the class width, and the frequency we don't know. Frequency we have to find, and the formula is frequency density equal to frequency divided by class width. This is the formula. Frequency density equals to frequency divided by class width. So using this formula, we can easily find this. Now we need to find the height or frequency density of this class, which starts from 7 to 8. 6.5 to 8.5. So it has to be this building, and it is clear it is 7. The height is 7. So from that we can write that the frequency is 7 to the 14. This is 7 times 2 equals to 14. The next one is, so this one 16 to 20, so this is 20.5 by continuity correction since there is a gap here, and this is 15.5. So this is going to be, either you subtract this for the class width, or you just subtract this and add 1. So 20 minus 16 is 4, plus 1 is 5. So the class width is 5. So the frequency we don't know, class width is 5, and the frequency density, so for that formula we have to look at this building block here. So the height is 1, so frequency density is 1, 5 ones are 5. So this is going to be 1 into 5 equals to 5. So question number A is done. In question number B, what we have to do here, estimate the number of motorists who delay between this to this. That means we have to find the area. The area is the frequency when they're proportional. Remember, area equals to K into frequency. So when we find the area, so area equals to K into frequency, we have to find the value of K to see what is the value of K most of the time. But here we can assume, since this is only 2 marks, we can assume that we don't have to go through the trouble of finding the value of K. We just assume K to be 1. So for this area, so let me show you where it starts from. So if we look here, this is 5 boxes, and this is more 5. So 10 boxes is 5. So 10 boxes is 5 unit. So 2 boxes is 1 unit, 1 box is 0.5 unit. So to start from 8.5 is to start from this building right here. So we have this region, this entire region. This is starting from 8.5, and then we have, actually this is 8.5 is this building. Also we have this building. So starting from here we have these 2 buildings. So 8.5 to this. So this is, we have to go up to 13.5, so somewhere around here. So this is 13.5, this. So we have 3 buildings now, 3 rectangles. If you pay attention, you know already 2. You know because if you do the lower class boundary, upper class boundary, 8.5 is here. This is 9.5. Then this is 9.5 lower boundary, upper boundary 12.5. So this is 12.5, so 13.5 is somewhere around here. So this frequency is 21 this frequency is 45, so we have to add up the frequency. Area is frequency, so we need this region, so 12.5 to 13.5. If we know that area, we can add up and find the frequency up to that point. So this is 12.5, and up to 13.5, that is, if you subtract it, it is 1, and the height is 3, so the area is 3 times 1, it's 3. So you can easily find this by adding up total number of motorists or total frequency equals to 21 plus 45 plus 3, which is 69. This one area or frequency is 21, this one area or frequency is 45, and this region is part of it, and we found the area using the rectangle from here, 12.5 to 13.5, where the height of the rectangle is 3 and the length is 1, so 3 ones are 3, and we find the total area to be 69. This is a set notation probability sum. The information is given. First of all, when we have intersection equal to 0, what does that mean? Obviously that means mutually exclusive. So question number A, mutually exclusive. Done. Question number B. Well, we know that event A and B are independent. So remember, if A and B are independent, so the formula of union becomes like this: probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. Now instead of A intersection B, we can now write the independent rule, which is probability of A into the probability of B. So this is very, very important. You have to remember that. So we can easily do this sum now. So probability of A union B is given. So probability of A union B is probability of A plus probability of B minus, now remember, A intersection B independent means probability of A times probability of B. So probability of A union B is given 2 by 3. Probability of A is given 1 by 4. Now probability of B is unknown. So let me write X here for probability of B. Probability of A is also 1 by 4 and probability of B is unknown. Let me write X here. So let's do the calculation. So 2 by 3 minus 1 by 4 is 5 by 12. And X minus 1 by 4X is 3/4 of X. That means from here we can find X equals to 5 by 9. So that is B. Question number C is A prime intersection B. So if you remember, the best to do sums like that is to use the Venn diagram. There are 3 sums where we need to use the Venn diagram. One of them is A prime intersection B. So if it is like this, probability of A prime intersection B, this, we need this region. If we have probability of A intersection B prime, that represents this region. B prime means remove B. If it was probability of A prime intersection B prime, then we'll be using this region, the outside region. So whenever you do a sum like that, you have to remember that for these three, advisable to use the Venn diagram. So let's see the Venn diagram. So in the Venn diagram, we have probability of B, which we consider to be X. So the entire probability, this is A, this is B. So probability of A union B is 2 by 3. Probability of A is 1 by 4 and probability of B is 5 by 9. So in order to find A prime intersection B, so we are looking for this region, A prime intersection B. So we are looking for this region. So from A union B, if we remove the circle A, we can easily find this region just by shaded area. So probability of A prime intersection B is equals to probability of A union B, which means this entire region, this and this, minus probability of A. So if you write 2 by 3 minus 1 by 4, you get, so it will be 5 by 12. Now I guess another way of doing this sum, which is since they're independent, you can easily write probability of A prime intersection probability of B is probability of A prime multiplied by probability of B. In that case it would be 1 minus 1 by 4 multiplied by the previous, which is 5 by 9, and if you multiply by 2 you get 5 by 12. But this is something that might be obvious, because it is not in every sum that they mention independent. It is only this sum they're mentioning independent. So this area is more more common way of doing this sum. The next question, question number D, is to find probability of B prime given A. So we can easily do this using the formula. Probability of B prime given A. This conditional formula is also given in the formula booklet. So this would be probability of B prime intersection A divided by probability of A. So B prime intersection A, in the previous sum we found A prime intersection B. So similarly we can find B prime intersection A is to be this region. So we can find probability of B prime intersection A is probability of A union B, subtract the probability of B, which can be probability of A union B is 2 by 3 and probability of B is 5 by 9, and if you subtract it you get 1 by 9. So once you know this, you can easily put it here. You can write 1 by 9 divided by 1 by 4, and the answer is 4 by 9. Of course you can also use the independent rule, since the mention is independent. So we can write probability of B prime into probability of A. Probability of A and probability of A cancels off, and probability of B prime is the answer, which is 1 minus 5 by 9, and that is 4 by 9. That way also you can do the sum. In this question they mention about 100 people and how they exercise. So when you have information like that and you're asked to draw a Venn diagram, it is a good idea to remember that there are 3 sets, because run, swim, cycle, that is the convention. So let's start from that. Draw a pretty big diagram, it's advisable. So draw a big diagram like that. This is run, swim and cycle. So run, swim and cycle. Remember, this is the universal set. The good idea to start from here. That is the first thing you write, and the last thing that you write is write the portion here where no one runs, swims or cycles. So let's start and see the last information. 25 do all 3. So this is this information, 25 do all 3. So 25. Now let's cover this region, intersection, run and swim, run and cycle, swim and cycle. Gradually let's cover that up. Run and cycle is 35. So if run and cycle is 35 and this is already 25, this has to be 10. Swim and cycle is 30. So this is 30 and this is 40. So swim and cycle is 30. So if swim and cycle is 30, then this has to be 5. Together they make 30. And run and swim is 40. This is 15. 15 plus 25 is 40. Now we know that run is 65. The entire circle run is 65. You can easily take later. So if this whole thing is 65 and this 2 is 40 and this is 50 and 65, this means it is 15. Now the next one is swimming. That is 48 swim. So if 48 swim, we have already 40, 45, so this is 48, 3. And finally we have 60 people cycle altogether. So that means if we have 35, 40, so this has to be 20. So 60 people cycle altogether. Now remember, once this is drawn, the final thing is this region. Do not neglect this. Most people forget. So out of 100 people, if you add all this up, you will see that 15 plus 50 is 30, plus 10 is 40, 40 plus this 2 is 30, 70, 70 plus 2 is 90, 93. So 100 altogether, 93. So this has to be 7. So that's question number A. In question number B, we have to find the probability that takes none of these cycles, none of these exercises. So probability of none is out of 100 people, there are 7 people. Remember, probability is total number of outcome is 100, and out of which one do you want? You want none, so that is 7. Question number C. In question number C, they say they swim but does not run. If swim intersection R prime, that is the probability they're looking for. So if people swim, it is this, and but if they do not run, then this region must be removed. They do not mention anything about cycling or not, so that just means out of the circle remove the run portion. So there are 8 more people who swim. That means, so probability of swim but not run. It's a good idea to write this out at least in words, so that the person who's checking your paper, they understand what you're doing. Question number D. In question number D, they said takes at least 2 of these types of exercise. At least 2 of these. So at least 2 of these, what does that mean? That means they do 2 of these, but they can also do more than 2 of these. They can do all 3. So this means all 3, 25. So at least 2. That means not less than 2, but they can also do all 3. So all 3 means 25. Plus, they can also do only swimming and running, which is 15. They can also do only cycling and running, that is 10. And they can also do only cycling and swimming, which is 5. That means at least 2 of these means this region, this region, they can do 2 or more exercises out of 100. That means if you add it up, this is 40, 50, 55 out of 100. Finally, question number E. Jason is in a group, given that Jason runs. Okay, now here the given information is Jason runs. How many people runs? That is the total. Now we have to select from someone who runs. So now this circle, we know 30, 40, 50, 60, 65 people is your total now, because you have to choose someone from runs. So probability of run, let me do it here. So probability of given run, you have to find the probability that does not cycle. So not cycle. So how many people runs? How many people runs is 65 people runs. And you have to find the people that swim but not cycle. So swim but not cycle out of this run set is swim and run is this portion, but does not cycle. That means it will only be 15. Swim but not cycle. This region would be cycle, run, swim all together. We need 15 out of 65. So that would be the probability.